cells culture a cell culture's population under appropriate conditions obeys the law of uninhibited growth. If 130,000 cells are present initially and there are 509,000 cells after 3 hours, how long will it take for the population of cells to reach 3 million? Round the answer to the nearest hundredth. Okay, so this particular problem has two major steps. The first one is to find k, and then the second step is to use our equation with k in it to find the answer. Okay, so step one, find k. So to do that, we use our formula A equals A sub 0 E, is it, okay, help me, R KT, right? I'm just trying to remember. So yeah, that looks right. Okay, so if we have 130,000 present initially, and now later we have 509. Now we could simplify this by cutting down on the number of zeros, but that's going to happen naturally here in a second when we divide stuff out. So k, and this is after 3 hours. So I've plugged in my initial amount, I've plugged in my amount after 3 hours, I've plugged in the 3 hours. So I divide both sides by the 130,000. So the good news is that this is just going to reduce to 509 over 130. Does it reduce further than that? I don't know if it does. I'm not going to stop and worry about it. Okay, so now we do natural log of each side. So natural log of 509 over 130 equals the natural log of e to the 3k. So then that gives us 3k times 1, because it's times the natural log of e, and the natural log of e equals 1. So 3k times 1, right? So that just gives us 3k equals this thing. So k would equal the natural log of 509 divided by 130 divided by 3. So there's our k value. We could get approximate decimal for it and use a big decimal as far as you can go to make this as accurate as possible, right? So that's the first step. Second step is to use it to solve the problem. So now we take our formula, A equals 130 e to the kt, but instead of k being an unknown variable, k is this thing right here, right? So we can just plug that into there, whether you change it to a decimal or just leave it as this ugly exact answer. So we want to know how long it's going to take to reach 3 million. So we want this first number to be 3 million. And that's going to equal that stuff. So then we want to divide. Sorry, I get lazy writing things sometimes. Don't be lazy when you're writing work on a test, though. I can just get rid of 4 zeros like that, right? So 313. All right, so then I can natural log both sides. So I have the natural log of 3 over 13. Oh wait, it's 300 over 13. Oops. And that equals the natural log of e to the kt. Keep in mind that we know what k is. We're just not writing it down right now. So then natural log e turns into 1. So I'm going to ignore that. So then t will just equal the natural log of 300 divided by 13 over k. And k is the natural log, unless you have a decimal you're going to use, natural log of 509 divided by 130, and then that whole thing divided by 3. So the fact of the matter is, if that's dividing by 3, isn't that the same thing as multiplying the numerator by 3? It might be easier to just use a decimal and plug that in there. So that's what I just put there. Okay, so I'm going to have 3 times the natural log of 300 to keep things as exact as I can until the last minute when I throw everything in the calculator. You could do the calculations sooner than that if you wanted to. I'm just trying to write everything out to make sure we know where everything came from. And my computer is having an increasingly difficult time of writing. Something's really bogging it down. 509, maybe it was better before. 1, 3, 0. There, that's better. I don't want that to be confused with the other part of the problem. Just shrink that down. That's just going to be part of that, not part of this. Okay. Calculate it. It wouldn't be a bad idea for you guys to practice with whatever calculator you're using. Make sure you know how to use the calculator you'll be using. Don't know where I put my calculator. Okay, so 3 natural log 300 divided by 13. If your calculator doesn't automatically put parentheses in there, please use parentheses where I wrote them down. And then divide that by the natural log of parenthesis 509 divide 130. Enter. So I got 6.898, blah, blah, blah. So that would be approximately, oh, that's weird. Oh, I'm looking at the answer key, and I got like 6.9 hours. And the answer key says 6.82. Can anyone tell me why? Because what? Did I round my k value? No, I used the whole thing in my problem. I used the entire k value in my problem. So that's what I got when I did that. Now, if I had done the k value on its own first, which probably is easier, because then you get less lost in the middle of what you're doing, and there's less likelihood of calculator error. So if I just do the k value, plug that in my calculator, I got 0.4549711. Well, that's interesting. This answer key approximates that at 0.46. But according to what I got, this wouldn't round to 0.46. It would just round to 0.45. So that would still throw off the answer slightly. It's okay. Obviously, there's going to be some leeway. So you're probably concerned, yeah, but Canvas isn't going to catch those types of things, you know? Well, maybe it will, depending on how it's set up. And the other thing about the question on the final that relates to this is they actually give you the equation, so you don't have to find k. It's not the 2 steps, it's just the 1 step. It's not the find k first and then find the answer, it's just take the equation, solve for t, find the answer. So that will help eliminate some of that possible error.